Alright, so the first example is a tank of water in the shape of an inverted cone is leaking water at a constant rate of 2 cubic feet per hour. Okay, so an inverted cone is a cone with the tip pointing downwards. So the volume, since it was cubic feet, that gives you the hint that it's volume. So dV over dt, it's leaking water, so it's losing volume. So negative 2 cubic feet per hour. The base radius is 5 feet. And the height is 14 feet. So on the top I have 5, and the height is 4. Okay, so your picture looks like that. So your water is slowly decreasing. So it's coming out the bottom. All right, so in this problem, your volume equation of a cone is V equals 1/3 pi r squared h. Okay, and when you're doing this problem, think about all the different things you know. So for part A, it says the depth of the water is 6 feet, so that's your height is 6 feet. And it wants to know the rate at which the depth of the water is changing at that point. So you want dH over dt, so the height of the water. Okay, so that means that I know nothing about dr over dt. All I know is dv over dt and dh over dt, so I want to replace any r's that you have with h's. Okay, so in these inverted cone problems, what we have are similar triangles. So when you thought geometry was going away, it never goes away. Okay, so your original was 14 and the top was 5. So your radius and height of the water are like that. So we have similar triangles. We know they're similar because they have the same angles. So by angle, they're similar. So what we have is R and H, and the whole thing is 14 and 5. Okay, so I have R over 5 equals H over 14. Okay, so when you cross multiply, you get 14R equals 5H. So if I'm solving for R is 5 over 14H. So that allows you to replace this R with 5 over 14H. So I get V equals 1/3 pi 5 over 14H squared times H. So when you simplify, that's going to be 25 over 196 when you square. So I'm going to have 25 pi on the top, and then 196 times 3, so 588 on the bottom. And then I'm going to have h cubed, because I had h squared times h. Okay, that's easy to take the derivative of, so dv over dt is just pull that number out front, so 25 pi over 588 is all just a number, so you're going to have 3h squared dh over dt. Okay, dh over dt is what you're trying to find. You know dv over dt is -2, so you have -2 equals 25 pi over 588 times 3 times, it says when the height is 6, so 6 squared, and then times dh over dt. Okay, so I'm going to take my -2, I multiply by 588, I want to divide by 25 pi times 3 times 6 squared, so 36. So you end up with dh over dt equals -0.139, so 3 decimal places, feet per hour. So those were your units. Okay, so let's say you panicked and you took the derivative right here and you solved and got the derivative was dv over dt equals, and you did product rule, so you had 2/3 pi r times dr over dt h plus 1/3 pi r squared dh over dt. Okay, so let's say you did that. So when you're trying to solve the problem and you realize that you didn't have dr over dt, that can actually be fixed. So if you made a mistake and then you found that you could you didn't have dr over dt, look at your proportion that you set up from your similar triangles. You can always take the derivative from that point, and you'd have dr over dt times 1/5, right? This is 1/5 r, equals, this is 1 over 14h, so it'd be 1 over 14 dh over dt. So then you could solve for dr over dt. So dr over dt would just be 5 over 14 dh over dt. So you could do that, and that would save you from a mistake. Okay. So let's go and look at the trapezoid one. So this is probably the hardest example that you'd have on one of your quizzes. All right, so the cross-section of a 5-meter trough is a isosceles trapezoid with a 2-meter lower base and a 3-meter upper base and an altitude of 2 meters. So right through there, so perpendicular is 2 meters. Water is running into the trough at a rate of 1 cubic meter per minute. So when you see cubic meter, that's your volume. So dV over dt is 1 cubic meter per minute. Okay, how fast is the water level rising? So we want to find dH over dt when your depth is 1 meter, so when h is 1 meter. All right. So we come up with our volume equation, and our volume equation is the area of the base. So in this case, our parallel bases are trapezoids. So the two shapes that are exactly the same and parallel each other. So our area of a trapezoid is 1/2 h times b1 plus b2. So I'm going to call b1 the upper base and b2 the lower one. It doesn't really matter, so whichever. Okay, so that's the area of the trapezoid, and then you always multiply by the length between them, or the height. It's usually called height. All right, so in this case, it said we had a 5-meter trough, so this is 5 meters. Okay, so remember I told you about that the crazy lady at the conference who refused to let people plug things in for constant values, and she made her students take the derivative of h, b1, b2, and l. Okay, so you don't have to do that. If something's constant, you can always plug it in. So if it's a constant rate, you can plug it in because, or if it's a constant number, you can plug it in because the rate is always going to be 0. All right, so things that are constant would be this 5 meters. And then B2 is also constant. Okay, B1 is changing because this started out, oops, I don't know why it's drawing there. Okay, you started out with a full trough. Oh no, it's filling, I guess. So you started out with an empty trough. So that's where B1 was, and then it's increasing, 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 increasing until it gets to be 3 meters. Okay, so B1 is not constant, B2 is. So I'm going to make that 2 and 5. So I have B1 plus, and then 1/2 h. And obviously h isn't constant because h is the height of the water. So it's obviously changing. So equals B. Okay, so I try to simplify before you take the derivative. So I have 1/2 h, so I'm going to have 5 over 2h times b1 plus 2. Okay. Now always before you take the derivative, like in the last example, you need to think about, oh, I just realized I didn't do part B on the last example. But whenever you are about to take the derivative, think about your different rates that you have. So we have dV over dt. We need to find dH over dt. We know nothing about dB1 over dt. So we need to eliminate this. Because we don't want to have dB1 over dt. Okay, so the hard thing about these trapezoids, I might need a new page. Let me try to draw it here. Is we can't say that we have similar trapezoids. So what a lot of people and me when I first learned these, I would think that this red trapezoid was similar to the bigger trapezoid because I'd say, well, they have all the same angles because you have all these parallel sides. So, you know, these angles are the same. Oops. Right? We know that all those angles are the same. And then we know the bottom angles. So since they're itself, so those blue angles are in both trapezoids, you would think that those are similar trapezoids. But similar triangles always have, you know, all the same angles, angle, similarity. But then we also have that all of the sides are in proportion. So these trapezoids cannot be similar because let's say this length was 5 and this one was 2. Well, that means that all of the sides need to be in that same proportion. So this one, let's say it's 3. Well, it's 3 for the big one as well. So it's 3 for both trapezoids. So therefore, they are not similar trapezoids. So you can't use like the same thing that you did with similar triangles. So we need to somehow create similar triangles. So if I'm drawing this, think about where you have triangles in this picture. Here is the triangle that's going to help us. Okay, so I'm going to call this value x. Okay, this whole length here is my B1 that I'm worried about, that I want to replace. Down here I had 2 originally. So if I'm cutting out these 2 side triangles, it was 2 down on the bottom and it was 3 along the top. So that means it's just 2 here. So that means that these 2 pieces have to be 1/2. So 3 minus 2 and then divided by 2. Okay, so we have similar triangles. So I'm going to use this similar triangle over here. So I'm going to have 1/2 equals x, and then I'm going to do over. So those were the bases of the triangles, over the heights of the triangle. So my height of my water, and then the height of the whole thing was 2. So I'm going to have 2, and then x over h. So I have 1/2 divided by 2, so 1/4 equals x over h, and I need to solve for x. So x would be 1/4 h. Okay, so under B1, think about what B1 is now. So I'm running out of colors. So looking at this length right here, B1 was x plus 2 plus x. So it's 1/4 h plus 1/4 h plus 2. So it's 2 plus 1/2 h. Okay, that's what we're going to replace in here. So V is going to be 5 over 2h times B1, which is 2 plus 1/2 h plus 2. So I get 4 plus 1/2 h in the middle. So I'm going to have 4 times 5 over 2, so 10h plus 1/2 h times 5 over 2h is going to be 5 over 4h. Okay, that's my volume. Let me get a new page here. Getting a little messy. I don't know if I can do this. So 10h plus 5 over 4h. Okay, now you're ready to take the derivative. So you get 10 dh over dt plus 5 over 4 dh over dt. Your volume is 1 and h is 1. I guess I don't. Did I leave off the squared? Yeah, I left off a squared somewhere. 5 over 4h squared. So this is going to be 5 over 2h. Okay, so h is 1, dv is 1. So So I get 10 plus 5 over 2, that's 12.5 dH over dt. And I divide it over, so I get 1 divided by 12.5. So 0.08. Okay, since that's an exact answer, you don't need the 0.080 to have 3 decimal places. You just need the 2 since it's exact. And your units are, it was in meters per minute. So your height is changing at 0.08 meters per minute. Okay, so that's how you do those. So always think about where your triangles are. So cut off the sides of your trapezoid. All right, going back to B on number 2, I realized I didn't do that. B, it says at what rate is the radius of the top of the water in the tank changing when the depth is 6 feet? Okay, so the top of the water is just it's just going to be a circle. So if you're looking down into the tank, it's just a circle that's getting bigger and bigger and bigger as I guess it's getting smaller and smaller because we're leaking water. Okay, so we have an area of a circle, which is pi r squared. And notice it's saying the depth of the water is 6 feet. Well, that's not telling us much about r, but we have this proportion from before. So you could plug in 6, so you'd have r over 5 equals 6 over 14, and you can find r. Okay, so you get 15 over 7 for r. So now when you take the derivative, no wait, I'm sorry, I'm totally telling you the wrong thing. I wasn't asking for the area changing, I'm asking for the radius changing, so let me think. So I want to know dr over dt for part B. And this is actually much easier because we know how to relate dr and dh. That's what I was saying here. So 1/5 dr over dt equals 1 over 14 dh over dt. So if you've already solved for dh over dt, you're just going to do 1 over 14 times that. Wish I had my exact answer in here still. And then you're going to multiply by 5. So it should be somewhere around negative 0.050, I think, feet per hour. Okay, and then the last example I wanted to talk about is the shadow problem. The shadow problems are in every textbook. So it always says something about a light post or a spotlight. So we have our light up here, and Tina is 5 feet 6 inches, so she's 5.5 feet. And she's walking at a rate of 4 feet per second away from the light that's 15 feet above the ground. Okay, I'm writing. I don't know why it's not writing. There we go. Okay, so 5.5 feet, 15 feet. Okay, she's walking away from the light. So let's call this distance x. Let's not. This is going to be the rate that her shadow is changing. Pen's a little off here. Okay, so this is her shadow is changing. Now think about it, as she's getting closer to the light, her shadow is smaller. So as she gets further from the light, the shadow gets longer. So if you need to see a sketch of that. So if she was real close, her shadow is just this long, right? If she's kind of far away, her shadow gets longer. Okay, so that's what's happening in this problem. Okay, I'm going to call x. That's the rate of change that she's walking away from the light. So she's moving at a rate of 4 feet per second. So dx over dt. And that distance from the light is getting bigger. So it's positive. Okay, so we want to know what ds over dt is. So A is find ds over dt. And we want to know what that is when she's 10 feet from the base of the light, so when x equals 10. Okay, so this is also similar triangles. So here's my one triangle, Here's my larger triangle. So when I set it up, I'm going to have 15 over 5.5, so those are the heights, equals this whole distance is x plus s over s. So 15s equals 5.5 times x plus s. I know my s's look like 5s, so I'll try my best. Okay, get all the s's on one side. And take the derivative. So 9.5 ds over dt equals 5.5 dx over dt. Okay, so what we've shown here is that the length or the rate of change of her shadow is directly proportional to the rate of change of her that she's moving away from the light. So what actually this means is there was no x in the problem. So we never, like, once we took the derivative, there's no longer an x. There's just the rate of change of x. So it actually doesn't even matter how far she is from the light, which is kind of counterintuitive because it's like, well, once she gets a certain distance, if she's like 5 miles away from the light, obviously her shadow is not going to be really, really huge because the light's never getting to her. But this would be, we're not thinking about like the speed of light and how light is affected by distance. So it's very different than a true like physics problem. But so basically, this doesn't matter at all in these problems, which is very confusing for students. Okay, so at what rate is the length of her shadow changing? We know dx over dt is 4, so I'm going to plug it in. Divide by 9.5. So you get 2.316. Okay, and that is in feet per second. Okay, now part B is a little bit harder. So it says, at what rate is the tip of her shadow moving? Okay, and I always hated these when I was in school, and I still think it's confusing, and I always have to like think about it before I teach it. Okay, so the tip of her shadow is being affected by her moving and the shadow getting longer. Okay, so two things are affecting it. So what we're doing is we're really thinking of this whole distance as like L. Sometimes you use a capital D. Okay, so this whole length. So we're really finding the length dl over dt, the rate that the whole length is changing. So dl over dt. Okay, so dl over dt, well, L was just x plus s. So dl over dt ends up being dx over dt plus ds over dt. So it's the rate of change of her walking, 4, plus the answer you just found. So it ends up being 6.316 feet per second. Okay, and on your test, I'm not going to ask you that. And if I do, I'll probably like give you a hint. I'll say, remember, the tip of the shadow means the whole length from the light post. So I'll make sure I give you a hint.